Hey everyone, today I wanted to provide an overview of APIs, or specifically what they are, when you might want to use them, and when you might not want to use them in an organization, as well as provide an overview of some of the content related to APIs. So let's dive right on in. Okay, so we got the slide going here about what is an application programming interface. And an API has multiple definitions depending on kind of what layer you're talking about. And what I mean by that is there are external APIs and then there are software level APIs. So, for example, the most common language that someone is going to be referring to when they're talking about an API is an external API. So, for example, I'm going to just pick a vendor. AWS happens to have a variety of APIs, one for each of their services that they have. So, Amazon EC2, a service responsible for launching compute instances, will have an API that provides capabilities external to the organization in order to be able to launch instances or to be able to list all of the instances that you have running in a particular region, as well as a variety of other operations on there. So, what is an API? Well, if we consider what a web application is and what the whole point of user experience is, that's designed to make interacting with software convenient, efficient, enjoyable for humans. An API, in contrast, is designed to make interaction between software components more efficient. So it's a structured way for software applications to communicate with each other, allowing different systems, and that's a key point, different systems to exchange data seamlessly. And I'm throwing quotes on there because seamlessly is kind of like whenever you get a quiz or a test that says always or never, always kind of have that little red flag up there because there are some challenges with APIs. So I guess the real question is, when do you want to build an API as an organization? And the rules for that are pretty simple. When you're big enough. So if you're a large organization, that's going to be very useful to have an API. Or if your organization is complex enough, meaning that you have different departments that need to communicate and exchange information, ideally in an automated way, that's when you're going to want to consider doing that. Another example is when you've been burned by getting your data screwed up in the database. So it's a common pattern for people to expose access to a system from one team to another via direct database credentials. And if permissions aren't carefully controlled, you could potentially screw that up. Another scenario is when your customers are actually asking for information regarding that access to the data. And of course, as any business, when you're going to make money, doing so is a great reason to do it. And then, of course, when you're coordinating with other teams, also another fantastic reason. Okay, let's talk about the Jeff Bezos API mandate. So in Jeff Bezos's API mandate, and now to be perfectly honest, I'm not 100% sure if this is in fact truly from Jeff Bezos. So Jeff, if you're watching this, go ahead and let me know if this was actually you, and if there's any corrections to make, I'll be sure to update the video here. But okay, let's dive into it. So point number one, in 2002, it's claimed that Amazon sent out an internal memo to the team. And it reads as follows. All teams will henceforth expose their data and functionality through service interfaces. Second point, teams must communicate with each other through these interfaces. Point three, there will be no other form of inter-process communication allowed. No direct linking, no direct reads of another team's data store. That's that direct database access example I gave. No shared memory model, no backdoors whatsoever. The only communication allowed is via service interface calls over the network. Point four, it doesn't matter what technology they use. HTTP, Corba, PubSub, custom protocols, doesn't matter. And point five, all service interfaces without exception must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose the interface to developers in the outside world, no exceptions. Anyone who doesn't do this will be fired, and then thank you, have a nice day. Wow, what a lovely way to end that. You're going to be fired, or if you don't comply, but thanks and have a nice day. So let's talk about this a little bit. There's some really interesting points in this that really stand out. I think we need to ask the question, what problems is the organization trying to solve? So in this scenario here, in 2002, Amazon was a very fast growing company. No question about it. In fact, they were growing really quick, but 2002 definitely predates a very large driver of Amazon's revenue today, which is AWS. And so in order to launch Amazon, the quote online bookstore, if you will, it's a lot more than that, obviously. But in order for them to do that, they needed to procure hardware, manage data centers, do all of the things a fast-growing technical organization needs to do. And so they had lots of departments that were communicating across each other. And if you've worked in any kind of large organization before, you might figure out like there are a number of ways that you might want to be able to ask for information from someone. So I'm actually going to skip ahead a little bit here to a point on, let me see here. Oh, actually, you know what? I didn't include that in this. So, oh yeah, this was the point, the slide that I wanted to show, which was, okay, how can you ask for information from your colleagues? Well, you could use paper forms. You could use a ticketing system. So if you want someone to do something for you, you might often hear the request, yeah, sure, can you get me a ticket in whatever the ticketing system is? And then after they've gotten bored and irritated with having to do that a bunch of times for different people, they might expose someone database access. Finally, they might build a little web application on a custom internal web server, or you might even go as far as building custom apps. So, all right, circling forward here. All right, we've read through the API mandate, and then let's talk about this. So point number 4 in Jeff Bezos' article talked about it didn't really matter what particular technology is being used. And in 2002, I think that's a really important point to make because a lot of these technologies were in flux. In fact, 2002, just right after the dot-com bubble bursting and all that kind of stuff, you had some challenges here. There was lots of protocols being developed. A lot of the internet was in flux. And as a consequence, it's hard to say exactly what technology needs to be used. I think the important bit, though, is that you solved a particular technology problem. So nowadays, what are some common technologies that someone would use? Well, of course, HTTPS is the most popular way to do it. Works on the web, there's lots of clients available for every single programming language out there that I'm aware of or ever worked with. There's always an HTTP client. And then there's other protocols too. So gRPC is another, quote, faster binary level protocol. And RSocket's also a really cool protocol built around streaming, but also can sit on top of HTTP if you want. Okay, so HTTP it can be broken down into a handful of methods or ways that you can interact with it. So these methods are sent in, and so you might say, I want to get a particular resource. So when you go to www.google.com, you are initially performing an HTTP GET request. The web server receives that and then returns information. But in an API, you might want to do other operations. You might, for example, want to rename a contact in a contact management system. That could use the put operation. If you want to create a new contact in a contact management system, that would be a post operation. And then the patch operation, while less commonly used, is allowed for partial in-place updates. So what that means is, like, let's say you have 10 fields on a contact, first name, last name, phone number, so on and such forth. If you only want to update the phone number, that would be a patch operation, providing just that one field out of all the possible ones being updated. Not all APIs implement that. And of course, the delete method is to remove a given resource. Options headers are used for CORS, that's cross-origin resource sharing. You can consider that a security level type of thing, or even listing what an API endpoint can do. And servers that comply with that will send information about what is available to run for that particular endpoint. Head is useful for cache validation. I haven't used that in APIs personally, but that is the scenario where you'd use it. And the HTTP connect method, it's used for tunneling. I've never seen it used for APIs. Of those possible HTTP methods, these ones here are the ones that you're going to be focused on the most. Okay, so HTTP as a protocol. How is it sent? Well, it is sent over TCP. That is a reliable form of network communication with the ability to retry requests over a period with a backing off delay up until you hit a timeout, unlike UDP. UDP is useful for streaming video, but it would not be a good choice for something where you require reliable transmission of the document in its entirety. So if you want to send video or you're doing a voice call with someone, for example, UDP is okay because you don't care if a few packets were lost in the past. All you care about is generating the most current audio as of now. If, however, you are uploading, say, a video to someone, maybe you're running a media editing company, you would want to send that over TCP, ensuring that the entire video is sent correctly, because it's not about time efficiency as much as it is about completion and correctness. Okay, so you have that get request method, if you will. Then comes a list of headers, which is split as a string, string, if you will. And then it may contain a body, and those headers can also be duplicated. And it's also important to note that HTTP is a stateless protocol. All right, headers. Here are some example headers that you might see in an API or in an HTTP request. So you might have a content type. You can request a particular content type, if you will. That's with the accept header, or a service might respond with it. Here's the particular type of content. This is an application JSON payload, or it may be an image like image PNG or image JPEG. You could also make a request over an API using an authorization header. This is what would be called a bearer token. So it's authorization : space bearer space, and then the token contents go in there. The body is often a string. It can be just any kind of arbitrary array of bytes, or it can be a stream for information that's sent over a long period of time. For example, if you wanted to say stream out stock ticker updates and keep that connection open, that would be sent as a stream. Most APIs follow a request response pattern though. You make a request and you get back an entire object. And this is a JSON payload here containing a title with some contents in there, an amount, and a value in there as an integer. So that goes to the URL that is structured as protocol, or if in the RFC, if you read that, they would say scheme : and then in this case here, we have a socket, which is an IP address and port combination, followed by the path and optional query string arguments right here. You can use a command line tool called curl if you're on Windows or Mac. On Mac, you may need to install that using Homebrew. I don't recall off the top of my head. And the -I will include all of the header information, and then you pass in a request. This, for example, by default is a GET request, since that's what most people do by default. Okay. Now, how do you know that your request is being secure? So if you're making banking transactions, there's a technology called TLS, or also known as SSL. You can use the terms interchangeably. TLS has replaced SSL, but people still call it SSL by default. And that's where if you're going to search, like I want an SSL certificate, that there are issuers that can provide that for a cost, or you can do that for free using Let's Encrypt as a service. And the most important thing to note about SSL is that it relies on a chain of trust being handed over. So your operating system will include a handful of certificate authority chain certificate files that can be used to verify that a domain's certificate is in fact valid. And so the real vulnerability in this whole model is, do you really trust every single CA certificate out there on your computer that the operating system vendor has decided upon? Maybe, maybe not. Generally speaking, they're really good choices, but for international people behind restrictive firewalls, you may want to be evaluating the CA certificates that are in fact used, that are being used to inject a man in the middle to inspect traffic. So be careful about accepting root level certificates if you join a wireless network or something like that that tries to say you need to have that network installed or that certificate installed on your computer. Okay. How do you stay logged in? APIs, generally speaking, are a stateless protocol. So previously I mentioned sending an authorization header, and you would do that on every single request. And that's true. But just for the sake of being somewhat thorough here, let's ask the question of how do you stay logged in on a website? And the answer to that is cookies, of course. Thank you, Crumble, for this delicious looking cookie image. That is the property of the Crumble Corporation and is not my own cookie. Okay. So let's talk about how we can view some of these API requests, if you will. So if we were to go to a website, I'm going to just pull up a local news website on my computer here, and I'm going to hit F12 in Chrome, and I'm going to get what's called the developer console. There's a way to do this in every single browser. Safari, you would have to go to the Safari settings and enable the preferences. And the thing that I want to show here, just with respect to what can be seen, if I'm going to clear out the history here and hit do a hard reload on here, the initial request is the interesting one here. You can see I've got that URL as mentioned here. And I can say I requested king5.com. That's just a local news area in the Seattle area. The request method was an HTTP GET. They gave back a status code, meaning that it's a 200 OK. And I'm sure if you've browsed the web enough, you might have seen things where you get like a 404 not found or a 500 internal server error. Maybe they have some fancy, picture rendered there, but these status codes are useful for applications consuming an API or a web page. And here's those list of headers that they send. They send a whole bunch of them in here. And in fact, you can even see that we've got some cookie stuff set in here. And there's a variety of tidbits of information that are interesting. My browser says, hey, I accept text HTML and these various other formats in here. And that is, generally speaking, what that looks like. And then they send back a response. This is that body, or I might use the term payload. And this is that HTML that comes back. So in this case here, you could say that the API for this website is that it returns with HTML content, and then the browser renders it, and that makes it useful. Then there's also AJAX requests. These are more often what you'd consider an API being used here. I'm just going to pull up a typical request here. I'm just grabbing the first one here because that's in there. And they're using some kind of consent check here. So they're saying, do we accept the cookies on there? And if so, and then they send all this information back and forth. And you can see, in this case here, this is a JSON payload that has been returned. And this is what it looks like raw. That's the preview version, so you can actually kind of navigate down. So if you want to understand how a website actually works, I would definitely check out the developer tab, and you can kind of check things out. One other thing you could do if you're using Chrome is you can click on inspect, and you can then actually navigate through and kind of poke at and modify how certain elements look. So I'm just going to, for example, inspect that headline, and I could modify the CSS and make that look different on this particular request. So if I was designing a web page, I might be manipulating the content on there. All right, back to the slides here. Oh yeah, and that is it. Okay, as far as the website of things goes, that's what that looks like. Let's dive into actually seeing what an API could look like. So in this case here, I am using IntelliJ, and I have a Spring Boot application. Spring Boot is a Java-based framework, and if you were to go to start.spring.io, you could pick the technologies that you need. I'm going to run through the dependencies here real quick because I think that's interesting, and that will help anyone who wants to build this out. So I'm using Spring Boot Starter version 3.3.5 on Java 23. These are the latest and greatest versions available. And there's a couple of dependencies that I have in here. I have validation. I have the web. This allows it to send back the templating stuff if I want to go down there. But more importantly, it allows requests and response to be formatted using a web server. I've got some testing capabilities in here. And then I'm using this dependency called mock MVC for REST docs. And this is for documentation. I have a plugin in the build process called ASCII Documenter. That'll be used for documenting our API. And then there is the ASCII Documenter Maven plugin. And then we also have the dependency within there, which is for ASCII Doctor. If I were to run this application and I were to now go to my web browser and I'm going to navigate to localhost 8080/docs, I can see some sample API documentation. In this case here, this service does something called creating a task, and I can perform an HTTP post method to it. Here's some headers that were passed in. Here's a payload. And then I can also be able to, the only documented method I have in here is creating a task. But I can get a task as well. So let's go through, and we have our application running. I can now go up to, I created these .http files. So let's run this first method here. And I'm going to click play in here. And you'll see in here that it returned back. You can see it says, hey, it's application JSON coming back. I got a HTTP version 1.1 200. That's the OK. It returned successfully response. And it gave me back an empty array. Okay, interesting. And notice I'm not focusing too much on the actual implementation. The whole point of APIs is that we could read documentation, and we could interact with our code. So now I'm going to post this payload here of this task. Hey, I'd like my lawn mowed and I'm willing to pay $5 to do it. So I'm going to post that. And that returned back the array as well as this content in here. And if I were to post it again, oh, interesting, it added another one. And if I post another one, it adds another one. Okay, cool. What about this get tasks endpoint? Let's go up to here and rerun it. And now, interesting, when I click get tasks, I have 3 of them returning back. So, okay, what's happening here? I'm making a request to this application server. In this case, it's running on localhost 8080, so my laptop, and it launched on port 8080. And it's making a request to this /API/tasks endpoint. Let's take a look at this. Okay, so I have this module here. For all Java applications, it's going to be located in source, main, Java, tasks. And in this case here, we have a handful of packages in here. But the interesting one is this one here, our tasks, quote, API. So I've defined a path that I want to listen to, /API/tasks. And now I can do a get mapping. So in this case here, this is empty. So if you're to think of what each one of these bits do, is they append on information to the overall request mapping. And so the get path is handled in this function here, get all tasks. And the post mapping will do what we're calling add a task in here. Oops, I'll hide those annotations there. Didn't mean to click that. And then let's see here. We can get those tasks. Oh, and then I have just an array list. So here you might use an actual database to store information over the long haul. I'm going to restart the application just to show what happens. But this information is stored in memory. And if I rerun get tasks here, you can see we get an empty result. If I were to post these tasks, 1, 2, 3, 4, 5, 6, 7, I don't know, something like that, rerun this, now you'll see we get a whole bunch of these back. So that information is stored in memory in our application, and we're not interacting with it. And then what we can do is we can just return the list of those, and the application then returns this list of them, and it knows how to marshal the information to the requested content type, which is application JSON. And then I can add tasks in here. So, okay, cool. But documenting an API is really important. So let's go down to the test. And actually, just to show for the sake of anyone who's curious about this, I have a task request, and this is a record. So it's like a class, but it has getters and setters all built in. And so I just have some validation in here. And this can be interesting too, because if you want to have an API do reasonably sane things, in this case here, let's say we only accept tasks with a minimum of $5 because we don't think anyone will do anything for less than $5. And we set the maximum value of $999 because in Washington State, I think you need to have if a project's more than $1,000, you might need a contractor license or something like that. So let's do that here, and let's set we're willing to pay $1,500 for someone to mow our lawn. That seems a bit crazy. And oh, now we got a HTTP 400 out. And then it said, hey, willing to pay the largest task value is $999. So if I set that to $999 or $900, which is less than that minimum, that says it's okay. And you can see we now have this new amount, and that got added, and it successfully saved it. So that's great. So how did we get the documentation done? All right, let's take a look at that. So in Spring, there is a way to test your applications, and I'm using a piece of software called mock MVC. It's built in once you have that based on the dependencies I have. And then I can say, hey, I'm going to create a task. I know that I've got an object that's shaped this way. So if I was building an API client, I would be taking a look at this information and say, oh, okay, I need a title, a description, how much they're willing to pay. And a good API would be documented with valid ranges and descriptions and things like that. But we're going very bare bones here. So I create this task request. I give it that information. It just has these same values right here that were used. And I then let me go back to the API test. I'm going to use the object mapper that then can translate an object to a JSON payload. So it can write that as a string. So I'm going to run this here. I'll just show you real quick by debugging it. I hit that debug button, and you can see this content is literally written as a string right here. So that's what the object mapper content value is that's written right here. So the output of that is a string, And now I can go down and perform this actual action. And so I'll run through that and we say it's okay. And that is what that looks like. So that builds that. And then the ASCII doctor will actually create this document called tasks create. So if I go into there and take a look at how that's configured, I've got these snippets, tasks/create, and you can see I've got this method, and then we can see what this actually does. So if we ran an HTTP request, this is the raw payload. If we were using curl, it gives us the command line that we could run. So if someone wants to be able to do this and be able to execute that manually, that's what they would run. So it's passes those headers, and we could even run this here manually. Let's copy this. I'm going to go to my terminal. I'm going to paste that in, and we get back the output here, which looks correct. This is our whole API, and it is returning the information in there. So that is APIs at a very, very, very high level. If you're interested in checking out this actual repository, you can find that on github.com/JackDPeterson, and the specific repository is going to be right here. So github.com/JackDPeterson, that's me, and INTC-3283 minus API minus documentation. INTC-3283 happens to correspond to a introduction to data management class that I taught in this fall of 2004. So right now it's the semester is just about wrapped up, but I was introducing students to APIs, and this is a online explainer of what that looks like. Hope you enjoyed that video.